Okay, so now in today's session we are going to see nested interval theorem. So what this theorem says that statement if In is a sequence of closed, bounded, non-empty intervals in R with I1 containing I2 containing I3 and so on, then intersection n is equal to 1 to infinity, In is non-empty. Moreover, if length of ion tends to 0, then intersection n is equal to 1 to infinity, ion contains precisely one or precisely or exactly one element. One element. Go through the statement. Are you getting my voice?
Yes, ma'am.
Yes. So what is given here? Ion is a sequence of closed, bounded, non-empty intervals. How is this sequence? I1 containing I2 containing I3. This is a decreasing sequence of intervals in R. And we have to prove if it is a decreasing sequence of closed, bounded, non-empty intervals in R, then their infinite intersection must be non-empty. And moreover, if length of ion tends to 0, then that infinite intersection contains exactly one point or one element that we want to prove. Okay. So how is this? Let us draw I1, I2, I3. Let's say I1 is nothing but A1, B1, I2 is say A2, B2, I3 is nothing but A3, B3 and so on. Okay. It is interval, closed and bounded, closed. Okay, sorry, I written open. So it should be closed. Closed and bounded intervals. Okay, so if N Bn is here, then where will be N plus 1 and Bn plus 1? N plus 1 will be this side and Bn plus 1 will be this side. Closed and bounded intervals, decreasing intervals, no? Right?
Yes, ma'am.
Are you getting this?
Yes, ma'am.
Which is the biggest interval?
A and B.
N, A1, A1, B1 is the biggest one. Okay. It is decreasing sequence. Then A2, B2 and so on. Are you getting this?
Yes, ma'am.
Yeah. So we will start the proof. We want to prove intersection is non-empty. Okay, so let in is equal to say an, b and c. N, B and C. Since ion containing ion plus 1. What can I say about sequence N? What can I say about sequence N? Here you can see. What should be relation between N and N plus 1? N must be less than or equal to N plus 1. For all N, right? Since ion containing ion plus 1, N must be less than or equal to N plus 1 for all N.
Yes, ma'am.
Yes. So what can I say about the sequence N? Whether it is an increasing sequence or decreasing sequence? This implies N is
Ma'am,
an
could you please repeat this?
which step? See, what is the statement and what we want to prove? We have given only sequence of intervals. How are the intervals? Closed, bounded and non-empty intervals. Okay. And how is that sequence of intervals? It is decreasing sequence. Decreasing, again I will draw it. Okay. If I am saying ion is equal to An, Bn, then where will be A1, B1? If A1, B1 is here, where will be A2, B2? This is my I1. Okay. Biggest interval, I1. Then where will be A2, B2? I2 is contained in I1. So it must be smaller. This will be A2, B2. Then A3, B3. And so on. So here somewhere it will be An, Bn, right? And somewhere here it will be N plus 1, Bn plus 1. Is that okay? Is that okay? Hello students. Are you getting my voice? Okay, so just I have drawn new diagram of intervals. Okay, so is this diagram is clear of intervals? Nested intervals. Nested म्हणजे एकात एक. I1, I2, I3 हे कसे intervals आहे? Closed, bounded आणि it is a decreasing sequence of intervals. So I have drawn like this. Is that okay? Please reply.
Yes, ma'am. Yes, ma'am.
Yes. So n is less than equal to n plus 1 for all n. So what can I say about sequence n? N is an increasing sequence or decreasing sequence?
Increasing.
It will be an increasing sequence. A1 less than equal to A2 less than equal to A3 and so on. Na? So n is an increasing sequence of real numbers. which is bounded above also, which is bounded above. Why it is bounded above? It is bounded above by, what is its upper bound?
B1.
What is its upper bound?
No.
Can you give me an upper bound? Since n is less than or equal to b1 for all n, right? b1 or bn also you can take.
Yes, ma'am.
Yeah?
Yes,
Or b1 is an upper bound, whatever may be your n. n is less than equal to b1 for all n. So n is an increasing sequence of real numbers which is bounded above. So if it is increasing sequence of real numbers which is bounded above, we know that it converges.
Yes, ma'am.
Yes, ma'am.
Which converges to its supremum. Therefore, this implies n converges to A, where A is nothing but supremum of n. Is that okay? Bounded above mannapeksha, it is not a set, it is a sequence. So I am saying it is just a bounded increasing sequence. Okay, it is not a set. So n converges to say A, where A is nothing but supremum of n. Now similarly, what can I say about Bn? Similarly, what is the relation between Bn and Bn plus 1? Bn and Bn plus 1. This Bn plus 1. Bn is greater than or equal to Bn plus 1, right? For every n. So it is a increasing sequence or decreasing sequence?
It's a decreasing sequence.
This implies Bn is decreasing sequence of real numbers, and which is bounded.
Yes, ma'am.
Which is also bounded sequence, since what is the lower bound? Lower bound
A1.
A1 is always what?
Less than.
A1 is less than or equal to
Less than.
Bn for all n, right? Lower bound, A1 is the lower bound for Bn.
Yes, ma'am.
Yes. So a decreasing bounded sequence. Just now in yesterday's lecture we have proved every monotone bounded sequence of real numbers converges, and if it is increasing it will converge to its supremum. If it is decreasing it will converge to its infimum. So since it is decreasing sequence, it will converge to, so Bn will converge to B, where B is equal to, say, what is this? Infimum of Bn. Is that clear? Is that clear up to now?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes.
Okay. Also, what is the relation between n and bn? N must be always less than equal to bn for all n. N is less than equal to bn for all n. So what can I say about limit of n and limit of bn? But limit of n is nothing but a, and limit of bn is nothing but b. So I am getting a is less than equal to b. Is that okay?
Yes, ma'am.
Now my claim, now I am claiming intersection n is equal to 1 to infinity in is nothing but this interval AB. I am claiming this interval is AB. How I can say from here, whatever limit of this sequence, where somewhere it will be A, and here whatever, so somewhere here it will be B. So intersection I want now, so it will be some. So my claim is this infinite sequence of intervals is nothing but AB, and I want to prove that these two sets are equal. How we prove sets are equal? Take arbitrary element of first set and show that it belongs to another set, right? How we prove? Usually A is equal to B. How we prove A is equal to B? Let X belongs to A and prove it belongs to B. Then take arbitrary element from B and prove X belongs to A, right? This implies A is subset of B. This implies B is subset of A. If A is subset of B, B is subset of A, this will imply A is equal to B. Is that okay?
Yes, ma'am.
Yes. So
Yes, ma'am.
take arbitrary element of one set and prove that it belongs to another set. So let X belongs to intersection n is equal to 1 to infinity in. If X belongs to this, then if X belongs to intersection, then X belongs to in for all n. This implies X belongs to an bn for all n, right? So this implies an is less than equal to X less than equal to bn for all n. Am I right?
Yes, ma'am.
Yeah. Now you take limit an less than equal to limit of X less than equal to sandwich theorem we can use, limit bn. So limit of n is nothing but A less than equal to X less than equal to B. Is that okay? So this implies X belongs to interval AB. So this, therefore, intersection n is equal to 1 to infinity in is contained in closed interval AB. Now I want to prove reverse. So let X belongs to interval AB and prove that it belongs to in. How we can prove? Let me check whether recording is. Yes. Let X belongs to AB, therefore A less than or equal to X less than equal to B, right? Now what is the relation between A and N? A is the limit of N,
Yes, ma'am.
or it is a supremum. A is the supremum. So N must be less than or equal to A. Yes.
Yes, ma'am.
Yes. And it is less than equal to X less than equal to B. And what is the relation between B and Bn? B is the
Infimum.
lower bound. Yeah, infimum. Greatest lower bound. So is that okay?
Yes, ma'am.
So this implies an, this is for all n again, n is less than equal to x less than equal to bn for all n. So this implies my x belongs to where? N, bn, and which is nothing but my in. That is for all n. Since it belongs to all intervals, x belongs to intersection n is equal to 1 to infinity, in also. So therefore, what I proved? Interval AB is contained in intersection n is equal to 1 to infinity in. So from 1 and 2, what I get? That two sets are equal. What is n is equal to 1 to infinity in is nothing but interval AB. Is that okay?
Yes, ma'am.
Now,
Yes, ma'am.
now I want to prove if length of each interval tends to 0 as n tends to infinity. If length of interval in tends to 0 as n tends to infinity, then this intersection contains precisely one point. So let length of in tends to 0 as n tends to infinity. If length of in tends to 0, what is length of in? Therefore, what is length of in? In is nothing but my n bn. What is length of in?
Bien.
Bn minus n, right? So therefore bn minus an, this sequence also tends to 0 as n tends to infinity, right? This is minus. Bn minus an tends to 0 as n tends to infinity. But where bn converges to? But bn minus n converges to b minus a, because bn converges to b, n converges to a, and we know that subtraction, then bn minus an will converges to b minus a, right? Therefore, what we must have? Therefore, b minus a must be equal to 0. Why? Why?
Tends to 0.
Because limit of a sequence is unique. Limit of sequence is unique. Here limit is 0 and here limit is b minus a. So b minus a must be equal to 0. So this implies b must be equal to, or a must be equal to b. Therefore, intersection n is equal to 1 to infinity in, it's interval AB, but a is equal to b means nothing but singleton element. So it contains exactly one element, and that's the proof. Is that okay? This completes the.
Yes, ma'am.
Yes, ma'am.
Okay, so whether you understood this theorem, nested interval theorem? Any doubt? Okay, so now we will go to next point. Now, well ordering principle. What it says that if S is non-empty infinite subset of natural numbers then the elements of S can be listed. That is, say n1 less than n2 less than n3 and so on. If S is a non-empty infinite subset of natural numbers, then we can arrange or we can list the elements of that S in the following order. Is that okay? Say here xn or then xn plus 1 and so on. This is well ordering principle. If we are having any non-empty subset of natural numbers, then that all elements we can list in the following order. Not xn, n1, okay, n nk I can write, nk plus 1 and so. Is that okay?
Yes, ma'am.
Now we will give the definition of subsequence. We will define a subsequence. In previous lectures, we have defined a sequence. What is sequence? Sequence is nothing but a function from set of natural numbers to sequence of real number x, any non-empty set, but if we want sequence of real numbers, then it is a function from set of natural numbers to real numbers, right? So xn usually let x from n to R be a sequence. Then any map restricted to infinite subset S of n, then any map restricted to infinite subset S of n is said to be subsequence of sequence X. If X, this is my sequence, usually our definition we write it is a map, so I am denoting it by X from set of natural numbers to R. Then if I restrict that domain to any infinite subset S, then it will become a subsequence. That is xk is nothing but a subsequence. It will be from S to R, where S is a infinite subset of n. Infinite subset of set of natural numbers. For example, you take any sequence, for example, say let xn is equal to n. Then can you give me a subsequence? There are infinitely many subsequence we can have. What is this sequence? 1, 2, 3, 4, 5, 6, 7, 8 and so on. So subsequence x and k, you can have set of even numbers, set of all even numbers. It is also an infinite set, right? Infinite subset of n, that is 2, 4, 6, 8 and so on. This is my subsequence. Or another, you can have set of odd numbers. This is again another subsequence. 1, 3, 5, 7 and so on. Is that okay?
Yes, ma'am.
Like for xn is equal to n, how we denote sequence 1, 2, 3, 4, 5 and so on. So what is my x1? x1 is nothing but 1. What is x2? x2 is 2. x3 is 3 and so on, right? 4. Are you getting this?
Yes, ma'am.
And when we say, if we drop some elements, then we will get a subsequence. Now for sequence of even numbers, what is xn? 1. Now this is my xn 1. For sequence of, what is this? xn 2. What about 6? It will be my xn 3 and so on. So this xn k is a subsequence of this original sequence x1, x2, x3 and so on. Is that okay? This is x5, this is x6. Is that okay?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. Now what is mean when we say a subsequence converges? When we say a subsequence converges,
When the sequence converges.
if that sequence converges, because subsequence is nothing but again a sequence.
Set of.
Remark we can write. Remark, a subsequence xnk convergence of subsequence xnk means what? Let yk is equal to xnk be a sequence, be a subsequence of xn, sequence xn. Okay, then xnk converges to x if and only if yk, this, if and only if this yk converges to x, and if and only if for every epsilon greater than 0, given epsilon greater than 0, there exists natural number n0 belongs to n such that, what will be the definition then? Mod of yk minus x less than epsilon for all n greater than equal to n0. That is So yk minus x less than epsilon for all n greater than equal to n0. That is mod of x and k minus x less than epsilon for all n greater than equal to n0. This to be k. Greater than equal to n0. Now next remark. Let x and k be a subsequence of xn such that n1 less than n2 less than n3 less than nk belongs to n, then nk must be greater than equal to k for all k belongs to set of natural numbers.